In this module, we continue talking about different type of circuits and looking at resistive type circuits. The objective of this module in this video, in module 4, we're going to identify resistance in series circuits and resistance in parallel circuits. We're going to simplify series parallel circuits, and we're going to apply Ohm's law to various types of circuits. There's no performance tests in this module. If you look at this schematic, and we see the power supply, the power source, which is in this location, and we see it here. We have, of course, conductors, and we have loads. We have 3 resistors, and resistor 1, 2, and 3. And we know in series circuits that the current is the same no matter where we take the reading. So if the system is 3 amps, everywhere in the circuit will read the same thing. The voltage will not be the same. The voltage, whatever the supply voltage is at this point, it will be divided up between these different loads. And the voltage drop will not be equal unless the resistance of each one of these resistors are exactly the same. So if they all have different resistance, each one of these will have its own voltage drop. So again, and when it comes to its resistance, the total resistance will equal the sum of each one of these loads. So if this 10 ohms, this 20 ohms, and this is 30 ohms, we add them together. 10, 20, and 30 equals 60 ohms of resistance. And so this is a basic series circuit. It's very simple. And if you know 2 of these criteria, either if you know the voltage or you know the resistance or you know the current, you can solve for the other, the missing one. So again, if we actually look at Ohm's law equals E equals I times R. And we can solve for the rest of them if you know algebra. So E equals the current times its resistance, or current equals voltage divided by resistance, and resistance equals voltage divided by its current. So those are the 3 basic formulas. You can memorize at least one of them. I always memorize E equals I times R until you can remember the rest of them. Because if you can mathematically figure it out, solve for the unknown, it's just using algebra to do it. So basically, that is the process as we look at the circuit and try to determine what the how a series circuits operate. A series circuit is very simple. However, we don't see many series circuits, and here's the reason why. We don't see a lot of series circuits because it shares the voltage. Whatever you have there is going to share it between each one of them. So it will never, each of the loads will not receive the full amount of voltage unless it was designed that way. So in normal buildings, we will see, or in the real world, I'll just put it that way, everything is wired parallel. All the loads would be in parallel, so they will all receive the same voltage. Here's one of the problems with series circuits. If one of the loads blow out for like a light bulb and wired in series, the whole circuit is dead because there's an open circuit. A parallel circuit, which we will get into, operates completely different. Each one of the loads or the branch lines receive its own amount of voltage, the same amount. Whatever the source is in a parallel circuit will be the same for each branch line in a parallel circuit. But it's very simple. Series circuits, it's very simple. Again, the current is the same throughout the whole circuit. The voltage is divided between each of the loads, and it is based on the resistance. So so resistance equals the voltage divided by its current. The voltage divided by its current. So here's another schematic, and we can see um, the resistance. We have 50 ohms, 75 ohms, and 100 ohms. And each one of these, uh, based on the voltage drop, will have its own voltage drop. But to figure out what the total resistance is, we just add them together. Add them together. So in this circuit, it adds up to 225 ohms of resistance. In the series circuits, again, all we have to do is just add them. It's nothing hard. You just look at it and add it. But in a parallel circuit, it's certainly different. We can determine uh, what the resistance in a parallel circuit. But here's a couple rules to need to remember. Number one, the total resistance will always be lower than any of the individual. So we have 2 ohms, 4 ohms, and 8 ohms. And the total resistance will be less than 2 ohms. It doesn't seem that way, but I'm just saying that's how it works. It is the reciprocal. Add the reciprocal each one of those resistors, and that will give you your answer. The reciprocal each one of those, then we find the reciprocal of your answer. Or if it's only two, you can use product over sum. I always use the reciprocal because you're usually going to have more than two. So this is the reciprocal method. To determine, you take resistor 1, divide it into 1, 2 would divide it in 1, then 3 will divide it, and so forth. They keep on going that way until you can solve for the problem. And then whatever your answer is, you would divide that answer into 1. Again, so if we looked at that first one we looked at, it was 2 ohms, 4 ohms, and 8 ohms. And I said it would be less than 2 ohms. And we can see the answer came exactly to what I explained. It is less than 2. So it came to 1.14 ohms of resistance. So again, that is how we determine. It could be product over sum if you have only two. So it says here, in a parallel circuit, the resistance is calculated by dividing the sum of the inverse values of the individual resistance by 1. So when you get the full answer, so if I divide 2 into 1, got 0.5. I divide 4 into 1, I got 0.25. And if I divide 8 into this, I would come with 0.125. Add those together, come to 0.875. I divide that into 1, and that's what the answer will be. Now, again, this when you start to get into more complex type of schematics, you need to simplify it somehow. And especially when you have combination circuits. If you have a combination circuit, you will certainly will be simplifying it to be able to find your answer. If you don't simplify it, you will not be able to come with the correct answer. So in this case, we have a parallel circuit and we have the power supply coming in. But here's the thing, keep in mind, in a parallel circuit, each one of these get the same amount of voltage. So if the voltage supply coming into this would be the same on each one of these branch lines. However, we're going to determine what the resistance is. So we got four different resistors and resistance and loads, and we can solve for um, each one of these individually. We can look at these two, product over sum. I can simplify even faster than that, I assume. but we also have down here, we could do product over sum. Product over sum is basically resistor 1 um, times resistor 2 divided by resistor 1 plus resistor 2. Solve for that, you have the answer. I could do that for both of these. But I simplified it, and it came to, again, they simplified it, and this is the answer. I really don't like the way they did it here, but it works. It works. I would just rather just solve it all in one time. And the answer would come to, again, if you look at it, the answer is 200 and, I'm sorry, is 25 ohms. But if you really look at it, it's 200 here, 200 there, 100 there, and get a 50 there. So the answer has to be less than 50. They're not telling you what the answer is, but I know if it comes out more than that or equal to it, I know that there was a problem. I need to check my answer. Again, this is what I explained about product over sum. Product is multiplying, sum is adding. So I take the two resistors, I can multiply them, and then add the same resistors at the bottom, divide it into the top, and you have your total. You do this when you have, like I say, two different. You say the total resistance of equal resistors in a parallel is found by dividing the resistance of each resistor by the number of resistors. That's if they all the same. And that's pretty simple too. If they are different, then you can use product over sum. Product over sum is still work no matter what. It's just less steps. So again, the total resistance of two unequal resistors in a parallel is found by multiplying the value of the two resistors and then dividing the sum of the two resistance. Again, here's a series circuit again, and we got this is a series circuit. It's not series parallel, but this is a series circuit. Is that if a circuit does not divide into branches, it is a series circuit, which this is. There's no branches. It's one path for current to flow. However, this is a parallel circuit. And again, if the circuits divide into separate branches, it is a parallel circuit. But if it's both, if the circuit divides into separate branches and there are also a series load, it is a series parallel circuit, or sometimes we call it a combination circuit. Now the current flows differently. So there's a time when we have to look at these combination circuits, and when it's a combination, you will have to simplify it to make sense of it. Again, we can look at this circuit here, and we can simplify it a couple different ways. We got a resistor here, and we got a resistor here. I could simplify it a little bit different than this. I can look at this portion here and make it a series circuit, and I can make this a series circuit. And so now I got two series circuits, and if I combine these three and then combine these two, I would only have two resistance, which is in parallel with each other. That's the way I see it, and to work it out. But they have they did a little bit different here. They took these three resistor 4, 5, and 2. 4, 5, and 2. This is 4, this is 5, and this is 2. 4, 5, and 2. And they put that together and then brought resistor 1 and 3 as a as series. I could, like I say, could look at this different ways, but if you can redraw it and make sense of it, you can. So this can be a parallel circuit right here. What this is. So 2 and 4 and 5 in series. 2 is in parallel. If you look at this, so I can solve for these two, and then I have this here. So let's look at the next slide and see what it looks like. Okay. So again, you have this is simplified. It's reducing a series parallel circuit. So to calculate the total resistance in a series parallel circuit, first calculate the effective resistance of the parallel components, then add it to the resistance of the series loads. Okay. So they simplified it again. They took the things that was parallel, solved for it. Then you can see everything like this here. So resistor 2 was 20. It's still 5. And you can simplify it even more now. So now let's go back to this here, applying Ohm's law to series circuits. And we did one already. We know that E equals I times R. And I equals E divided by R. And R equals E divided by I. And so to find the voltage across individual resistors in a series circuit, first calculate the total resistance in the circuit. And the way we do that is by adding the resistance together in series. So next, use the total resistance in the Ohm's law equation, E equals I times R, to find the individual voltage drops. So once we know what the current is, we know what the resistance is, we can determine what the voltage is. Okay. Here's a parallel circuit. Again, applying Ohm's law to a parallel circuit. Is that in a parallel circuit, the total current is equal to the sum of the branch currents. So the branch current is equal to the applied voltage divided by the resistance of that branch. So when it comes to a parallel circuit, each one of the circuits, each one of the branch lines is independent. It's independent. So you got to solve for each one of those. One thing we do know, the voltage is the same for each one of the branch lines. The current for each one of the branch lines is going to be separate. It all depends what the resistance is. Resistance. Then you can determine what the current is. So again, we can look at each one of these separately and determine. So the voltage here is the same here, the same here, the same there. The current can be different. Once we know what the resistance is, to find out what the voltage is, and or find what the current is, we know the voltage is the same. Let's say if you knew what the resistance, you could take a meter and measure it. Then you could determine what the current is in this circuit. The same for each one of these. So here's an example. We're going to apply Ohm's law in this circuit. So the current in branch R2 in this circuit can be calculated as follow. So we can use the formula in a parallel circuit. It's the sum of each individual branch lines. It's the sum. So all we have to do is add them together. So we have 20 minus 2 equals 8. Or better yet, we can look at the current. We can find the current. The total is 20. Or if we knew what the resistance is, we can definitely determine what it is. And so normally we would know what the voltage is. We can measure it. We can de-energize the system and take a resistance reading. We can determine what that is. Now, if we didn't have a meter to read current, we can mathematically determine what that is. So here's an example again, just showing you what the total current in the circuit is 35. if we knew what the current through one of the circuits. But I think we kind of working backwards here because we can subtract and find out. But here's what, again, it would be the sum of each one of these would be the total. So here's a circuit where we have the total voltage and we know what each one of the individual resistance are. So again, now all we need to do is solve for this. First was simplify it, then we can solve for it. And so again, the voltage is 1.5 volts, and we got some resistance, two 1,000 ohm resistors and two 500 ohm resistors. That 0.5 K is 500 ohms. And so again, we can solve for it, product over sum, because we have um, two of the same. We could just add them divided by the number of they have, or we can be able to um, determine, like I say, product over sum. So again, if we did that, this is how they work the problem out, product over sum. 1,000 plus 1,000 times 1,000 divided by 1,000 plus 1,000. So again, 1 divided by 1. Uh, this is this is a mistake here. Um, yeah, this is definitely a mistake. 1,000 times 1,000 is not 1,000. I need to add a lot more zeros to it. Hope everyone see that. And the other slide we just saw. But mathematically, you can work it out. Would be 6 zeros on it instead of the ones we saw. So here we can simplify a series parallel circuit. And again, 1,000 plus that last problem we just saw, just simplifying is what we have. So it's basically, if you simplify it, it's a simple series circuit. And when it's a series circuit, the resistance just add together. And now we can determine what the answer is. Okay, now we can look at Ohm's law. Looking at this problem, individual voltage drops are calculated by using Ohm's law because we know voltage of each one of the branch lines. Here's a secret. Once we simplify it, to go back to solve for each one of the individual, you have to build it back out again. Once we simplify it to its simplest form, then we can work it out to allow the problem to expand back out so we can figure out each one of these individual loads. So what I like doing is making a chart of each one of the resistors. And when I start to simplify the problem, I have that information written down. And then when I start to build it back out to the original um, um, schematic, I will be able to use that same information I just wrote down in that chart. So here's some problems or questions that which you should have these terms for your assignments. Parallel circuits basically is a circuit containing two or more parallel paths or multiple branches through which current can flow. Series circuits, it's a circuit that has only one path for current to flow. And a series parallel circuit is a circuit that contains both series and parallel current paths. Here's some questions for us. Which of the following is true regarding a series circuit? It has more than one path of current to flow. That doesn't sound right because we know series circuits have only one path. The current flow is the same through all resistors. Well, that is actually true because we said that no matter where we check um, the resistance, the current in a series circuit, it would be the same. C says the current flow varies depending on the strength of the resistor. That is not true. In other words, the current flow would be the same in the series circuit, and it won't depend on a resistor. It doesn't matter if one resistor has more resistance or less, the load have less, it doesn't matter. Current will still be the same. D says the current flow through the resistor is always lower than the source current. That sounds more like a parallel circuit to me, so that is not right. So the correct answer is the current flow is the same throughout all the resistors. Next question says, which of the following is true regarding a parallel circuit? A says it has more than one path for current to flow. That sounds right. It's a parallel circuit have multiple branches, so multiple paths for current to flow. B says the resistance is the same throughout all the circuits. Well, no, that sounds more like a series circuit to me. C says the total resistance is equal to the sum of the individual resistors. Now, that sounds like a series circuit too, so that can't be right. So D says the current flow through each resistor is always less than the total resistance. The current flow through each resistor is always less than the total resistance. Now, basically, they're trying to fool you with it. They're throwing both questions together. They're talking about current and then actually about resistance. So the correct answer is A. It has more than one path for current to flow. All these was either trick questions, answers for you. Number 3, which of the following is true regarding a series parallel circuit? Remember, a series parallel has both um, series and parallel for current to flow through it. So, which of the following is true regarding a series parallel circuit? A says, once reduced to an equivalent series circuit, the total resistance is found by adding the reciprocal of each resistance by then dividing it by 1. Now, that doesn't make any sense because it says once been reduced to a series circuit, there's nothing you need to do if it's been reduced to a series circuit, because the series circuit says that um, how the current will be the same throughout the circuit. And if it's a series circuit, we don't have to worry about a reciprocal because that's what we do with a parallel circuit. So let's go to B. B says the resistance is the same throughout all the circuit components. Well, we know that in a series circuit, the current is the same throughout, but they say the resistance is the same. Well, C says if a circuit is reduced to an equivalent series circuit, the total resistance is found by adding the loads. Well, we know in the series circuits, we want to find out what the resistance is. We do add them. But it said if the circuit is reduced to an equivalent series circuit, the total resistance is found by adding the loads. Okay, that sounds okay. And D says the current flow through the resistor of each. Of course, my head is blocking the answer. So let's just pop this up. It is C. It is C. It is true. Next question says two branches of a circuit, resistor 1 and resistor 2, across a 120 volt power line draws a total line current of 30 amps. Branch 1 takes 15. What is the current in 2? and branch resistor 2. Okay, this is let's go back to this again. 2 branches across, so branches meaning that it has to be a parallel circuit if it has branches, because we know series circuits do not have branches. So if 2 branches in a series circuit across 120 volt line draw a total of 30 amps, and one is 15, and the other in the branch line. So here we do know in a parallel circuit is the current, which is the amperage, is the sum of each individual branch line. So if the total is 30 and one branch is only 2 branches and one is 15, the answer has to be 15.